Independence of events. A card is drawn from a standard deck of 52 playing cards. Now let's just remind ourselves, we have 4 suits: hearts, diamonds, spades and clubs, and each of those has 13 cards making up the 52. So the probability of drawing a diamond is 13 out of 52, and of course that cancels down to a quarter. The first card is a diamond. A second card is drawn without replacing the first. What is the probability it's a diamond? Well, I've removed one of the diamonds from the pack. And now we only have 51 cards because we didn't replace the card we took. So that would be 12 out of 51. And that's an example of a conditional probability. So these situations are not independent. We want to draw a tree diagram for the drawing of the 2 cards based on diamond and not a diamond. So, diamond, not a diamond. So we know this one is 13 out of 52 for the first card, and then this one must be 39 out of 52. There's 39 other cards. So diamond, not a diamond. Diamond, not a diamond. Well, if we got to here, that's the situation we discussed in part B. So this would be 12 out of 51, and this will be 39 out of 51. But if we didn't draw a diamond the first time, we still have 13 diamonds, and we'd only have 38 other cards because either we'll have drawn a heart or a spade or a club, so one of those will be down to 12. So this one will be 13 out of 51, and this one will be 38 out of 51. Is the situation dependent or independent? Well, it's dependent because we can see the probabilities change based on what's happened before. So originally 13 out of 52, and it's changed here, and also the probability of getting a diamond is different here. So the probabilities are dependent on what has gone before. A card is drawn from a standard deck of 52 playing cards. What is the probability of drawing a diamond? Well, we've discussed this. It's 13 out of 52, or a quarter. A second card is drawn after the first is replaced. So when we draw the second card, the deck is exactly the same as when we drew the first card. So that must be 13 over 52 again. We now want to draw a tree diagram for this situation. So we have diamond, not a diamond. So this will be 13 over 52, 39 out of 52. Now this time we actually replaced the card back in the deck. So when we draw the second card, whether we got a diamond or not, the deck is exactly the same. So it's 13 out of 52, 39 out of 52, 13 out of 52, 39 out of 52. Is the situation dependent or independent? Well, this one is independent, and we can see that because the probabilities are the same irrespective of what happened before. Identify the following situations as either independent or conditional. Conditional is the same as dependent. A blue and a red dice are thrown, and the red dice scores a 6. Well, that should be independent. What comes up on the red dice should not depend at all on what happens on the blue dice. A bag of sweets contains toffees and wine gums. Julie eats one sweet and then chooses a toffee. That would be a conditional. When she eats one sweet, she's changed the contents of the bags, which would change the probability. 2 cards are dealt from an ordinary pack of 52 playing cards, and the second is red. Again, that's conditional. We're dealing 2 cards, so that's going back to the situation where we take a card and don't put it back. A $1 coin and a $2 coin are tossed, and the $1 coin lands heads up. That should be independent. What happens with the $1 coin is not dependent on what happens with the $2 coin.